Now the only difference today is we are going to use the quadratic formula to find the x-intercepts. Now in the previous lessons we have factorized the quadratic to work out our x-intercepts. Now in this lesson we're going to use the quadratic formula to work out the x-intercepts. So let's quickly revisit our quadratic formula. Now this is what we learned in term 2. So using the quadratic formula we can find the solutions to a quadratic using the formula x equals minus b plus or minus the square root of b squared minus 4ac divided by 2a. Now remember I asked you to all memorize this as part of our math bar challenge. Now one of the most important parts of the quadratic is what's under the square root. Now if you recollect that, we called that as the discriminant. Now the discriminant tells us some important piece of information about the quadratics. If the discriminant is greater than 0, then our quadratic function has two solutions. Which means if we go ahead and sketch the function, it's going to cut the x-axis at exactly 2 points, which means that's our two solutions. Similarly, if the discriminant is equal to 0, then our quadratic function is only going to have one solution. If we sketch a quadratic with one solution, that's going to touch the x-axis once, and it's going to have exactly one solution. And finally, if our discriminant is less than 0, then we're going to have no solution. So which means our quadratic is basically going to be hanging up in the air, which means it's never going to cut the x-axis. Now let's go ahead and do an example. So we are going to try and sketch y equals 4x squared minus 2x take away 3. And while sketching, we are going to label all important points. So, when we talk about important points, obviously the first one we start with is our y-intercept. So to find our y-intercept, we substitute x as 0. So if we substitute x as 0, we get the y value as minus 3, which means our y-intercept is going to be 0 minus 3. Now, second step, obviously, we are going to try and work out our x-intercept. So to work out the x-intercept, we replace y with a 0. So which means we now have 4x squared minus 2x take away 3 equals 0. Now comparing that with our general form gives us a equals 4, b equals minus 2, and c equals minus 3. Now, why do we need to use the quadratic formula? Let's check that out. So if I go a times c, that gives me the answer as negative 12. Now, if I look at the pairs of factors for negative 12, so we can have minus 1, 12, or minus 12 and 1, minus 3, 4, 3, minus 2, 6, and 6 and minus 2. Now, all these different pairs, they give us negative 12, but they do not give us the value for b as negative 2. And hence, we can't use our normal factorizing techniques. So we can't use a normal factorizing technique, so we're going to use the quadratic formula to work out the x-intercepts. So the first part of using the quadratic formula is we work out the discriminant. The discriminant is b squared minus 4ac. So let's work that out first. So b is negative 2, so minus 2 the whole squared, take away 4 times negative 3. Please use your brackets for the negative numbers. So that gives us a positive 4, and multiplying those three numbers gives us a positive 48, which means the discriminant is equal to 52. Let's go back to what we discussed earlier. So discriminant is greater than 0, so which means we are going to have two solutions for this quadratic function. So one final step. X equals minus b plus or minus the square root of b squared minus 4ac divided by 2a. So let's put in the values. B is negative 2. We've just worked out the discriminant is 52. 2 times a, which in this case is a positive 4. So the two solutions for this quadratic function is x equals 2 plus the square root of 52 divided by 8, and x equals 2 minus the square root of 52 divided by 8. Now, in order to sketch these points on a graph paper, we need the approximate value for each of these x values. So we're going to load up our CAS calculator, and we are going to find the values for each of these x-intercepts. So 2 plus the square root of 52 over 8, that gives us the value as 1.15. So this is equal to 1.15. Similarly, the second x-intercept, so 2 plus the square root of 52 divided by 8. My bad, that's a negative. Control divide. So control enter. That gives us the value for the second x-intercept as minus 0.65. So our first x-intercept is 1.15 and 0. Second x-intercept is 0.65 and 0. So the one last thing we need to do is to work out the coordinates of turning point. Now we're going to learn a new method to work out the x-coordinate of the turning point. So there is a formula we are going to use in this particular section. The formula to work out the x-coordinate of the turning point is given by minus b over 2a. So if we apply that to this particular question, the value for b is negative 2, value for a is positive 4, which gives me 2 over 8, or 1/4, or 0.25. So the x-coordinate is a quarter. To work out the y-coordinate, we substitute that into the equation. So 4 times a quarter, take away 2 times quarter, take away 3. If you put that in your calculator, we get the value as negative 3.25. So which means the turning point for this quadratic function is 0.25, comma, negative 3.25. So one final step, we are going to sketch this quadratic function. So y-intercept was 0 minus 3, x-intercepts were 1.150 and negative 0.65 and 0, and the turning point was 0.25, comma, negative 3.25. So let's sketch this quadratic function, marking my y-intercept 0, negative 3, my x-intercepts and my turning point. And once that is done, we just have to finish it off with a beautiful looking curve. That's it for today.